This video covers green chemical approaches for the synthesis of a molecule by microwave synthesis, biocatalyzed reaction, and a solvent-free reaction. In that, we concentrate on the advantage and condition required to carry a solvent-free reaction. So, in this video I discussed based on the VTU Belagavi syllabus, engineering chemistry syllabus. So restricted to a very less. Briefly, I discussed this the synthesis method. First, I'll consider how we carry a microwave synthesis. It is a green chemical approaches. So here reactions are performed under microwave conditions. If we perform a reaction under microwave condition, we can able to carry that reaction very fast, clean, and give much better yield than the similar reaction under conventional conditions. So that's why the microwave technology or a microwave method to get the product is an efficient and safe technology conforming to a green chemistry requirement. It shows the green chemistry requirements. Then, microwaves are the electromagnetic waves having a shortest wavelength of radio spectrum. So here they possess a low energy compared to other radiation, and that energy is sufficient to break the chemical bond. So the energy of microwave is about 0.0016 electron volt at 2450 megahertz, which energy is sufficient to break any chemical bond. Microwave assisted synthesis becomes a special nowadays. Why? Because the heating effect, the efficiency caused by microwave energy, which reaches and absorbs directly to the substrate or the substance. Or the reactant mixture we take, so it directly reaches to the energy or the heat it's directly reached to the substance. There is less loss of energy. Then selectivity, having dielectric polar molecule which will absorb microwave energy, and there is an enhancement of chemical synthesis by microwave effect or non-thermal effect. So these things are comes under 12 basic principles of green chemistry. So that's why microwave assisted synthesis is considered under a green chemical approach. How the microwave absorbs heat energy. The microwave absorbing materials are most important of microwave chemistry. That means we cannot use all the materials for microwave assisted synthesis. They should absorb microwave energy. So based on that, there is two main mechanisms involved. That is, one is a dipolar mechanism, other one is a conduction mechanism, the dipolar polarization and the conduction mechanism. In dipolar polarization or a dielectric phenomena, the molecular dipoles in entire bulk tend to align with electric field of the microwave or rotate or oscillate to follow the changing the field. See, if you apply a electric field, say I'll consider this is I apply an electric field, okay, and electric field I applied, okay. Then the molecules, they contains a positive and negative charges, so they align themselves, okay, like this, negative positive charges. As a bulk, as a whole bulk, it will align. See here, a dielectric phenomena, if you consider the molecular dipoles, the entire bulk, that is here it possesses a dipoles. So entire bulk, they tend to align with the electric field. This is an applied electric field. They tend to align with the electric field of the microwave. As a result, these molecules rotate or oscillate following the changes in the field. As the electric field changes, here also their dipole moment will change. As a result, the movement of molecules results in the oscillation or a friction between the molecule. When these molecules, they move, dipole molecules, they move. As a result, they collide with each other. The collision or the friction between the molecules takes place. This results in the dispersion of energy, and as a result, they lost their kinetic energy. The kinetic energy, that is the energy possessed by the molecule, gets lost. As a result, a heat is created, and this is what we call it as a dielectric heating effect, which is a collective phenomena of the bulk. The entire molecules gets heated up. And in ionic conduction mechanism, again, when we apply an electric field, so I'll consider this is an applied electric field. When we apply electric field, here the molecular migration will considered as an ionic migration. Again, there is a collision between the molecule take place. Okay, here in ionic conduction, the solution containing charged particles, ions, they oscillate under the influence of electric field. Here, when we apply electric field, they oscillate, they migrate, they collide with each other. Okay, electric field of the microwave, and they collide with each other, molecules or the atom. So when they collide with each other, their kinetic energy possessed by the molecule is changed into heat energy. That is, the kinetic energy is lost in the form of heat. So the conduction of or the heating of this molecule take place. Here in ionic conduction, that is, here we consider as an ion, the solution containing charged particle, they oscillate under the influence of electric field of the microwaves. As a result, they collide with each other. They lost their kinetic energy and they get heated up. So the molecules gets heated up. Whereas in the case of dipolar polarization, here the molecular dipolars in entire bulk, they tend to align with the electric field. That is, molecules are migrating, or molecules, they try to align with the electric field of the microwave. They rotate or oscillate. So as a result, they lost their kinetic energy in the form of heat. See, there are two basic principles involved in this. There may be there are two more principles. I am not discussing all those here. The conduction mechanism is much stronger interaction than the dipolar mechanism with regarding to heat generating capacity, because individual movement is observed, whereas in the dipolar movement, the bulk molecules get aligned themselves. So it will take time. So that's why the conduction mechanism is much stronger interaction than dipolar interaction. Coming to the example, I'll quote one or two example of microwave synthesis. The microwave assisted synthesis of benzoic acid using benzamide. Here the reaction usually takes at 140 degrees Celsius and it will take 7 minutes. Within that 7 minutes, 99% conversion is possible. That is, the yield what we get by this microwave synthesis is more compared to the conventional method. The conventional method, we can achieve only 90% of conversion. Say the benzamides under the influence of microwave assisted synthesis at 120 degrees Celsius in the presence of 20% sulfuric acid and heated to about 7 minutes, we'll get a benzoic acid. Then saponification of methyl benzoate in aqueous sodium hydroxide under microwave condition. That gives around 84% yield of benzoic acid. In the saponification reaction, methyl benzoate or reaction with sodium hydroxides giving me sodium benzoate. The sodium benzoate further dissolved using the HCl will get a benzoic acid. And here, that reaction time required to carry this process is only 2.5 minutes. If you go a conventional method, so minimum reflections of about 4 to 5 hours is required. So that this is better compared to the conventional method. Then, what are the advantages of microwave assisted synthesis? Here, in a microwave, as you already observed in the example, it is a rapid process. Rapid and uniform heating is possible. The entire reaction mixture gets heated up and the same temperature, it will attain a same temperature throughout the reaction. No selective heating of the surface. At one particular area, some like it requires 160, another part area 60 degrees. It's not possible. Uniform heating, no selective heating of the surface, energy saving process, because the process is completed within a fraction of minutes, like within 10 minutes maximum of within 10 minutes. So energy saving process. Higher yields, shorter preparation time, purity in final product, because what the product we get, it is almost more than 80% conversion is possible. So the unused reactant or the byproduct formation also we can recover very fast, so that the purity in a final product is observed. Less solvent usage, reduction in unwanted side reactions, environmental heat loss can be avoided, and low operating cost. So these are the some advantages we observed under microwave assisted synthesis. Now, the next one, green chemical approach is using biocatalyst. The biocatalyzed reaction. What are biocatalysts? It is a natural substances, usually that includes enzymes, from biological sources or old cells to speed up chemical reaction. To speed up, catalyst is used to speed up the chemical reaction. In place of metal catalyst, if you use a biological sources catalyst like an enzyme, if that speed up the reaction, if the enzyme initiate the reaction, then those reactions are comes under biocatalyzed reactions. The enzymes have a pivotal role in the catalysis of hundreds of reactions. That includes the production of alcohol. That is a familiar reactions from fermentation. Then even the daily life cheese by breakdown of milk proteins. These are the good examples for biocatalyzed reaction. Many drug substances are difficult to synthesize. While synthesizing a drug substance, it is difficult to synthesize those type of some drug substance because of involving multiple step, large amount of solvent, extensive purification is needed. So that time, in order to avoid the side effects, we have to take into consideration of these things. So in place of some catalyst, if you use an enzymatic catalyst method, we can avoid these things like multiple steps, solvent usage, etc. The using enzymes as a catalyst can improve the purity and reduce the amount of organic solvent is needed, resulting in a much greater overall manufacturing process. Then the biocatalysts are broadly classified into 6 categories. Oxidoreductase catalyst, which involves oxidation reduction process, enzymes involved in an oxidation reduction process, transferase, that is to transfer the functional group, this type of catalyst is active, then hydrolase for carrying hydrolysis process, lysase, enzyme specialized in the addition or removal of water or ammonia or small molecules. Isomerase, as the name itself, for isomerization reaction, and ligase, so catalyzing the synthetic reactions where two molecules are joined by ATP. Then, example for biocatalyzed reaction. The biocatalyzed reaction, the good example is the fermentation of sugarcane juice. That is, biocatalyzed catalysts are used in the industrial preparation of ethanol. So what is ethanol? Is prepared by the fermentation of molasses. That is nothing but a dark colored liquid left after crystallization of sugar, which still contains around 40% of sugar. So how we carry this process, how we convert molasses into ethanol? The process of fermentation actually involves breaking down a large molecule into a smaller ones in the presence of enzymes which act as a biocatalyst. The enzymes used for this process is invertase and zymase. Here, the sugarcane juice we kept for fermentation process at a temperature of about 28 or a room temperature for few days. And during this process, we'll introduce a very little quantity of acid to increase the pH value. Ammonium nitrate is added as a source or as a food for enzymes, and yeast is added as a source of enzyme. That yeast contains invertase enzyme and a zymase which help for the conversion of sucrose into ethanol, and the whole thing is kept for fermentation. The fermented liquid of called wash containing around 18% of ethanol, then it is distilled, will get it's possible to get even 100% of ethanol. So sucrose on hydrolysis in the presence of invertase enzyme forming glucose and fructose. Further, the glucose or the fructose, they undergo zymase, or in the presence of zymase they produce ethanol with the evolution of liberation of carbon dioxide. This reaction catalyzed by a biocatalyst or enzyme. Then another example is enzymatic conversion of ketone to lactone, which is encountered by a microbial degradation. So cyclohexanone is converted into lactone using a cyclohexanone oxygenase enzyme, and NADPH undergo reduction, help for the reduction, and oxygen help for the oxidation process. So this reaction takes place with the help of oxygenase enzyme. Then what are the advantage of using biocatalyst? The enzymes are completely biodegradable, thus environmentally acceptable one. There is no need of recovering the enzymes. So it is completely biodegradable one. They are renewable catalysts. They act under a mild condition. They work under a pH of about 5 to 8, and the temperature range is maximum of 40 degrees Celsius. Enzymes are compatible with each other. There is no side reaction or a very less observation. Side reaction is observed. Less byproduct can be immobilized and reused, has the ability to differentiate between enantiomers. Then the third type of method, or the method adopted under green chemical approach, is a solvent-free reaction. Again, comes under microwave-assisted reactions. A solvent-free reaction is a chemical process that takes place in the absence of solvent. Without the use of solvent, this reaction is carried out. Or a dry media chemical reaction, or a solid-state chemical reaction, each of which may be referred as a solvent-free reactions. Here, the media becomes dry. We are not using any solvent. Without the use of solvent, only the reactant molecules make it to a homogeneous mixture, and then it is kept it in a micro oven, so that after a few minutes we can get the product. So each of which may be referred as a solvent-free reaction. Dry media reaction or solid-state chemical reaction is a chemical reaction that takes place in a system in which there is no solvent. In solvent-free reaction, the radiation is directly absorbed by the substrate and not by the solvent, because we are not using any solvent. So there is a very less amount of energy is sufficient, or the less time duration is sufficient, because solvent is not used. If we use a solvent, that takes a larger time to heat that solvent. Heat is directly, or the radiation is directly absorbed by the substrate and not by the solvent, thus increasing the benefit of microwave irradiation. Energy saving is increased, and the effect on yield and the selectivity is more marked. Thus, the solventless reaction minimizes the production of byproducts or waste by avoiding the use of conventional volatile organic liquid. Solvent-free approach involving grinding, ultrasonic irradiation, or microwave irradiation of undiluted reactants or catalysts by the surface of inexpensive and recyclable mineral supports such as alumina, silica, clay, or doped aluminosilicates. So these are used as a supporting component to carry the solvent-less reactions. It's not in all cases. In some reaction that take place via mineral support. In some reaction, even just by grinding a product is possible, and in some reactions by applying ultrasonic, this reaction is we can achieve the product, or we can able to get the product. Like, say, what are the conditions required to carry solvent-free reaction? There should be a homogeneous system. That is, a reactant should mix to form a homogeneous system. So homogeneous phase is required. Viscosity of the reactant should be very high. The viscosity should be high, suitable only for non-solvent assisted chemical reaction. It's not applied to all the reaction. It's not possible to carry all the reaction by solvent-free reaction only, or it is suitable only to those components which can able to carry a non-solvent assisted chemical reaction. There should not be any side reactions. So during this process, there should not be any side reaction. So if any side reaction is there, then again, there is a cleaning. It requires a cleaning process. Taking care of uniform heat dissipation and avoid thermal runaway. We are not using any solvent, so that's why the thermal runaway may observe. That is complete volatilization and the charring of that compound may observe. We have to taking care of uniform heat dissipation and the time required to complete the reaction we have to manage. Then we can avoid the thermal runaway. Then what are the advantage of associated with this use of solvent-free system over the organic solvent? See, if you are not use any solvent, the one thing is the reaction becomes clean, efficient, and economical technology. Because for solvent, there is a large, we have to invest amount or the money on to buy a solvent. So large quantity of solvent is required to carry the reaction. If we avoid the solvent, then it is economically benefited one. The cost gets reduced. The toxicity of the solvents are reduced to make environment friendly approach. Otherwise, the solvent toxicity may be included in the product. Here, the toxicity of the solvents are reduced, makes environment friendly approach. There is no reaction medium to collect, purify, and recycle a simplified workup. There is no media to collect that product, purify that product, or the recycle is required. Safety increased significantly, then reaction time can be rapid, often with increased yield and lower energy usage. Larger amount of reactants can be employed, the reactivity is enhanced, and in some cases the selectivity is modified without dilution. So these are the main advantages we observed under solvent-free reactions. Thank you.